Yes. So hi everyone. So we'll get started soon. I think today Akash is going to present a really good topic. I think also it's very important also, right? Like always we write React code and we see some unnecessary renders, and oftentimes we want to understand why this is happening. I think today's workshop will be very helpful, and and uh, and we can do a lot better after understanding the basic core principles of React rendering. So Akash recently joined Meta and he moved to London as well. And yeah, thanks Akash for joining all the way from London. Yeah, thanks for taking time for this workshop. So without any further delay, I think we'll get started. Um, I think meanwhile, a few more people can start it, might join, but yeah, we can get started. Let me make you the host. Yeah, yeah. Finally,
Okay,
I got the co-host option. Yeah,
awesome.
yeah.
So yeah, hello everyone. My name's Akash, and thanks to Kiran for the wonderful introduction. So today I want to talk about a topic which is very dear to my heart, which is basically optimizing and controlling renders in React. But I decided to rename the talk to the complete React interview guide, because I think that what I'm going to be showing today is going to be very relevant in your interviews as well. So since about November of last year, I've been giving interviews at several big companies. I tried to avoid DSA as much as possible. I only gave interviews at companies which took JavaScript focus interviews. And from these interviews, I've had several insights, several questions which came up repeatedly. And based on that, I've created this talk. So I've created like several mini versions of this talk before and presented it. One of which as one of which was at the previous Reactify conference as well. But not the online, I mean, the online conference, of course, not the physical one. But today I'm going to try to give you a complete breakdown of this topic, which is the complete React interview guide. And yes, as Kiran said, I'm currently in a new country in a hotel because I don't have a place of my own here. And yeah, I'm relying on hotel internet for this. It already made me disconnect from Zoom once, but hopefully the rest of the rest of the workshop goes well. So yeah, here we are. I will be explaining React and optimizing React to you. So firstly, we should understand performance. Why are all of the engineers on Twitter focused on performance so much? Why are we all worrying about performance all of the time while creating our apps? Or or why should we be worried about performance? So yeah, the answer is uh, that performance is what gets your users to use your platform, and more users, I mean, the more performant an app is, the more likely you are going to use it. You of course have read lots of like performance case studies about this already. Google likes to throw that number around, that if a user is spending more than 4 seconds waiting for a website to load, then they drop off. And of course, we don't want users to drop off from using our app. We want them to continue to use it, to recommend it with their friends, etc., etc. Again, like, think back to your own usage patterns of apps. You are more likely to use an app when it is more performant. You will, while discussing with your friends about which app they use for either payments or tracking their finances, or doing some sort of search, like, searching for a restaurant to go to, you're more likely to recommend apps which load faster, get their data faster in your face, etc., etc. And yeah, why should companies care about performance? I mean, they're getting more users, but that's all right. But what actually happens? Well, basically, the more users you have, the more they're using your app, the more money that the companies are making. So this is the actual reason why companies care about performance, and why you should care about performance as well. That is to make the company more money, and hence, increase our salaries as software engineers as well, because that's what we are here for, helping the companies make money and making money ourselves. So yeah, this is why you should care about performance, and hence the stickiness of the app. And of course, there are other factors which are involved in making users use your app even more. So there are other topics like product management and things like that which go into this. But this is a nice question that you can put forward to your interviewer in your interviews about what other metrics do they think about while building their apps, and you can use this in further interviews as well. So yeah, that was about why we care about performance. Now, how do we solve performance? So this part kind of goes into the system design of web apps a little bit, but this is also very interesting, I think. So there are three main ways in which you can optimize the performance of a web app. Since this is a React focused talk, I will be talking about web apps here. The first one is network optimizations. Network optimization are basically how fast your app load once you click on it, and how performant the app is while you're doing search queries, moving between the pages inside of your app, stuff like that. And yeah, what we have on screen right now, I hope you can see my screen though, by the way, because I've been sharing it. So what you can see on screen
Yes.
is like a, yeah. So what you can see on screen is like a list of things which are generally good to talk about when talking about network optimizations. So bundle splitting, of course, you only send the core of the page while while doing the initial render on the client side. So you only send the core JS, some utilities which were called in the main page, and then the theming of the components which are displayed on the page. The second very obvious point is compression. So compressing JavaScript files using gzip or Brotli, and then compressing images into smaller, more packaged formats as well. The more interesting one, I think, is HTTP2. So HTTP2 is generally not something that the developer has to worry about. It's generally available out of the box if the user's browser is supporting HTTP2. But it's something something interesting to talk about during interviews, because HTTP2 allows the client to multiplex multiple requests into a single TCP connection. So instead of making several TCP calls, a single TCP call is used to make multiple requests. So it's much faster in that way. And then CDN is again a content delivery network. That's something which most of us already know about, but it's good to note that down. Secondly, we have JavaScript optimizations. So JavaScript is basically some additional computation that you are doing after you have already rendered your page. Ideally, you want to ship 0 JavaScript with your code. But if we ship 0 JavaScript, then a lot of us wouldn't have our jobs today. So what we are trying to do is ship less JavaScript. So we are trying to do less stuff with JavaScript and do it more asynchronously, so the user's performance isn't affected as much. The main things that you can do is memoization of callbacks and results. So basically caching of results as much as possible, so you don't keep running the same computations again and again. Where you need to run some functions or computations again and again, for example, while a user is doing their search, I mean, they're searching for something inside of your app, then the results will be different all of the time. So you can use things like throttle and debounce there. And the rest of the points, again, like web workers are a pretty new concept. I don't think they have that great of an abstraction available right now for us to use, but it's good to like go into the depths of these things and learn about them as well. And then inlining critical CSS scripts. So if a script is needed while loading the page, then just ship the script with it, because then all of it can be parsed in a single pass, and we don't have to wait for the network and all of that. And then SSR goes back into our first point, which is don't do JavaScript at all. So just ship all of the stuff to the client at the same time, and then don't worry about JavaScript running on the client side if possible. And then do stuff in asynchronously. So there's something called party town, which you can note down or Google. So it is used to load third party scripts asynchronously and then run them on the web worker thread. So it avoids blocking your main page and improves performance as well. And the last point in optimization. So we talked about network optimizations, which was, sending less number of things over the wire. We talked about JavaScript optimization, which was running less JavaScript on the page. And now render optimization, which is basically about doing less number of renders and hence, using less number of DOM nodes, which makes the app much smoother. And to be honest, if you take one takeaway from this talk, it should be that renders are the most expensive thing in a browser, because a user can have a fast network, so that solves the network optimization problem even if they are downloading like heavy assets. And if they're a good 5G network, then they don't worry about that. JS optimization, I guess you should worry about it a little bit, but if a user has a good enough device, then you don't worry about that. But render optimization, so this requires much more expensive hardware, because JS can run on the CPU, but renders generally run on the GPU. And not everyone will have the latest and greatest phone all of the time. So you should maybe worry a little bit about reusing existing DOM nodes, not making as many renders. So that actually results in a much higher FPS for the user, like the frames per second that the user sees while using your app will be higher, and hence they will have a much better experience. So I think render optimization is a very important topic, and the points here are something that you might have learned about. So the first one is virtualization and pagination. For virtualization, we'll go into the depths of it later, but basically we use existing DOM nodes while creating a list instead of rendering all of the DOM nodes at once. And since we are reusing, not creating new ones all of the time, that results in less number of DOM calls being made and making the renders much faster. Secondly, since we are not creating new DOM, I mean, again, this ties back in the previous one, pagination is the same. We are trying to avoid making as many renders as possible by just having a fixed list on a screen at a time. So this is actually quite interesting. Try what happens when you try to render 500 items on your page. What happens when you try to render 5,000 items? Eventually, you'll see that even the best machines start to crash or the page starts to lag. And when you're browsing apps with infinite lists like Twitter or Facebook, that problem never occurs. And that's because they're using things like virtualization. And again, I'll go into the depths of this a little bit later. And then reducing CSS reflow triggers. So CSS reflow is something that a lot of us don't learn much about, but that's something that you should try to Google and see yourself. So there are certain CSS properties which, when you modify, it causes the GPU to kind of re-render parts of the app around it. So that is also a very expensive process uh, in terms of processing, I guess. So uh, yeah, since render optimization is the most important optimization that we can make, React is the tool that we are using, because React tries to optimize your renders as much as possible. It tries to batch DOM node updates into a single JavaScript like document.query selector call, and tries to update it all at once instead of making several like jagged calls and then your user having a bad experience while using the app. So yes, we will try to break down how a render in React works. So there are 4 very high level steps which occur when you are trying to make a render in React. The first one is that you're writing the code in JSX. I think this is the part that that us as developers have most control on. And then the next steps are something that we try to make inferences on and try to optimize as much as possible based on the code that we are writing. So I've tried to include that in the PDF as well. So that's why the first step is that we are writing the code in JSX. The second is transpilation. So JSX is not something that React can understand. You know that already when you look at the actual React code. It's something, there are react.create element calls in there, then react.render is called every time to make a paint on the page, stuff like that. So that final code is generated from your JSX using transpilers. The most popular ones are something like Babel or even SWC, which is created by Next, the creators of Next called Zeit. And the third step is the generation of virtual DOM or abstract syntax tree. This VDOM and AST is generated based on the react.createElement calls, which were transpiled from the previous step. And then when we are getting the tree, so basically you already know that React is immutable and you can't modify the React virtual DOM object directly. Even modifying state causes a lot of problems. So why is that? That is because React is generating a new version of the abstract syntax tree for every render. And this is why this process is a little bit expensive, because it's generating a new tree every time. And then it's comparing the previous tree and the next tree via a process called reconciliation. So I haven't written that on screen, but if you search for reconciliation, so this is the process that React uses to compare two versions of the virtual DOM tree. And then it determines which changes to apply on the screen. And those changes are applied on the fourth step, that is the DOM paint. So in DOM paint, the changes that were detected in the previous step are applied as a batch operation. So this is much more efficient than the code that you would be generally able to write by hand. And these four steps that I talked about, they are actually two steps which are they are generally applied in two phases. So the first three steps, which was code transpilation and generating the virtual DOM, they are generally called the render stage or the render phase of the React compiler, where the virtual DOM is actually rendered virtually. And then the commit phase, where once those changes are detected, they are committed to the DOM. So that is what is known as the commit stage. And now what I'm going to do is I'm going to show a bit of a code example about how this works in the actual React code base, so we can have an idea about this. So yeah, I've just opened VS Code here. I'm going to zoom this in a little bit. Is this visible? I think this should be more visible, right? With the zoomed in.
Yes.
Okay. Yeah. I'll just hide the floating controls for the zoom. Hide floating. Okay. Thanks, Rohit and Kiran. So yeah, right now I have a very simple counter example. Again, counter is the most boring example that you can take while explaining React, but it's also the most simple because you know how this works. You have seen it every time. So yeah, I have a very boring counter here. I have a state variable called count and set count. With the initial value of 10, I can just set this to 1 because that's more understandable. And then I have a button which increases count by 1 every time I click on it, and then just the counter variable with the count being passed to it. And I mean, again, this is a very simple example, so I'll just refresh this, and oh, I think I need the server running. Give me a sec. And yes, that should be running now. It's actually quite amazing how Next.js has optimized their app throughout the years, and the framework is just getting faster and faster to load. So yeah, here we have a simple counter example, nothing surprising here. I guess I'll zoom this a bit. And yeah, whenever I'm clicking on increment, the counter is increasing. At the same time, I have my console here because we are going to do a bunch of things with the console as well. So right now we were talking about the commit phase and the render phase. So the render phase is actually when the virtual DOM is run, when the code runs. So when the component that I've defined as vDOM here, when the code tries to run through it, then I mean, that phase is basically the render phase, which happens on the JavaScript side of things, not on the browser. So we can console log render here and try to see when a render is occurring. So if I click on increment, then every time I'm clicking on increment, a new render is occurring. We know that because whenever set count is called, whenever set state is called from the useState hook, a new render occurs. So that is happening as expected. And at the same time, if we go here to the actual DOM element, we can see that the DOM element itself is updating. So the commit phase is also occurring. And now to see the difference between the commit phase and the render phase, I mean, to see that sometimes the commits can occur, sometimes renders can occur without actually committing to the page. Let's see what happens when we remove count from here, or if we just add a static number. And then again, this is something which is very obvious and you might have seen yourself, but just as an explanation. So now if we click on increment, the render console log keeps getting called, but we can't see any changes on the DOM here. So we can see that multiple renders can be called without making a single commit. So that's why we are generally trying to optimize for the render phase, because if we try to reduce renders as much as possible, then we are eventually also reducing the number of commits that we are making. So that's my example for that. And that's something that you can show and tell your interviewer as well. So yes, the next topic, which is also very interesting, is how does React identify DOM nodes? So we learned about the virtual DOM. We know that React generates the physical DOM nodes that we see here from the virtual DOM that it is generating internally. So how does that happen? Firstly, let's try to see the structure of a DOM node. So we can actually do this by, creating an element here. I will take this line and put it inside of this element, and then I'll return the element here. Now, we have already seen that the actual code that we are generating, it eventually gets converted into virtual DOM element by transpilation, by a transpiler, and then the react.create element calls being made. So we can actually do console log on our components. So element here is a component, of course, and we can console log this to see what its abstract syntax tree object would look like, or its React Fiber node would look like. And if I refresh this, it will just display it directly. It should display it directly. So we can see it contains all of the properties of that node in React format. So it says that it's a React element. It has the props of uh, children counter 10. So again, because we are, this is the child element which is being passed to the React, that we can do children and then pass this in here as well, like counter 10, and that's how it is rendering it. And then its type is div. It has a owner, which is a fiber node, which has a bunch of internal information, React information that we can't completely understand, and we won't try to either. So this is how the virtual DOM, how a virtual DOM node looks like, and its implementation, React's current implementation is called fiber. So each node in this fiber tree is called as a fiber node. And how does, whoops, I should have opened that in a new tab. I can just close this, I think. And yeah, I think my internet is a little bit flaky right now, but this link basically shows how React stores. Yeah. So yeah, I will drop this link in the chat as well, I think, so people can have a look at how this works. So this is how the current implementation of React Fiber is, and how each DOM node is identified inside of React. But again, there is a very interesting but here. Even though React generally is good at identifying DOM nodes by its own, you know that sometimes you have to pass the key property. So what does this key property do? And that is what we are actually going to have a look at in this slide. So key is used to identify DOM nodes whenever you are using a structure like an array, because in an array you can dynamically add elements or remove elements from the array by yourself. And so while doing that, React can't really keep a track of how you're moving things around. So that's why you're passing your own key props to help React identify it. And we are going to have a look at that that exact scenario right now. What I'm going to do is I'm going to first create an array of random elements, which I'm going to display on the screen. So let me just go to my keys page. Okay. Oh, that's interesting. So what is happening here? Yes, I'll try to remove the React. Okay, I think we can ignore the errors for now. But basically, what I'm doing in this component, I'll break this down one by one. So I have a generate random array function here, which generates a new array of 5 elements, fills it with zeros because I need to initialize the array somehow. And then I am mapping over each of those elements and then replacing them with a random number between 0 to 100. And what I am doing here is rendering this list on the page initially with the key being the index of the array. So what is happening here is the index which is being passed is not unique because the key which is being passed is not unique because index will be reused throughout the elements. And how is it exactly being reused? So we have the array state variable here. I am using useState here and initializing it with generate random array. So at the start, array contains 5 random elements, which are being called using generate random array. And then whenever the add elements button is being called, I am adding 5 random elements to the start of the array. So it's like we are pushing 5 random elements from the top. So indexes are being reused. So eventually we should start seeing unexpected behavior here. So yeah, I don't know why I'm seeing like these errors from Babel today, but let's ignore them for now. So yes,
Maybe because Akash, you are generating numbers randomly, right? Numbers are
yeah,
different on server render and the client render.
yeah. That's exactly what I'm thinking. Maybe that's what's happening. And then I'm seeing, this is very new for me. I'm just seeing these random like React refers to a UMD global error today. It's
Okay.
just Windows things, I guess.
Yeah.
Yeah. Oh, although you seem to be right because like the numbers here seem to be different, and then the numbers which are being rendered on the client are different as well. So yeah, that's probably what's happening. So yeah. So we have 5 random numbers here. When I'm adding elements, 5 new random numbers are being generated. So nothing unexpected is happening till now. Everything's working fine. But what happens if the child component, which till now is just displaying the data which was being passed to it, holds some state of its own as well. So if I do something like internal state, set internal state is equal to use state data, and then I try to display this internal state in the child component as well. So initially, these are the child components which were displaying the data which was being passed to it, which was the random numbers which we were generating. if I instead try to store that state, try to store that data prop inside of a state, and if I refresh this page, let's ignore this again. So you can see 43, 92, 90, 87, 45. And if I try to add elements, now you can see what's happening. The previous array is being copied over. This is because React doesn't, since we are reusing the indexes, React is thinking that the same elements should be present there. So it will just keep doing that. And as we keep clicking on add elements, okay, I can no longer do that. Let me zoom out a little bit. It will just keep repeating the same 5 set of elements because the index remains the same. Now, the actual way to solve this problem is to generate random IDs for each of the element in the array that you are using. Right now, since in my function, we saw that we were already generating random numbers, let's try to use the number itself as the key for the element as well. So I can do something like %, element for the key. And now if I refresh this page and if I try to add new elements, now we no longer see the problems. Now we no longer see the problem which was previously occurring of duplicated elements being displayed across the array. So this is why passing a key in is important whenever you are trying to display array, and how you can help React in identifying the individual DOM nodes. I think this might have been a little confusing in the way that I might have explained it. So if anyone has any questions, please feel free to ask right now. Or is everything good?
So, Akash, every time we are changing that key also, for example, there was one array. So previously it was from 0 to 4, right? And again, if you are appending some values, so again that index is getting changed. So that time it will re-render, right? But it's not re-rendering after changing that key also. It should re-render, right?
After changing which key, sorry?
No, so see here, you are every time appending some new array into this array, right? Every time on click of that set array. Or you are generating that same array every time.
No, we are appending new elements. So what is actually happening is that since I'm appending to the start of the array, not the end of the array. So let me go back. So when we had this initial 5 sets of elements, so we had the indexes of 0, 1, 2, 3, 4. So the current indexes on screen are 0, 1, 2, 3, 4. When I'm clicking on add elements, I'm actually appending to the start of the array, not to the end of it.
Okay, got it.
So
thanks.
Yeah. So we are doing something which React is not expecting. So what is happening is when I'm clicking on add elements, the first 5 indexes are being reused, and the elements that we had previously, their indexes are changing. So that's why when we are using non-unique indexes, for example, I'll go back to using index here, and if I refresh the page, then whenever I am clicking on add elements, because the indexes are being reused, then React gets confused and it just duplicates those elements. So yeah, with this example, you can kind of see that, whenever you start seeing unexpected behavior with React, then you know why it is occurring, mostly because you are reusing index as key everywhere. And keys are actually quite interesting because whenever you change the key, React thinks that that element should be replaced with another element, and you can use this to do very interesting things. So for example, form resets. I have an example for that here as well. Let's go to the code to understand what's happening here. So I have a very simple form. I have got this component form here, and I am logging when the component mounts. Most of you might know how UseEffect works. whenever the component gets mounted, and if you have the dependency parameters as an empty array, then on the initial mount, the useEffect runs, and whenever the component gets unmounted, then whatever you pass in the return function in the useEffect is called. So in this case, we get unmount. So I have this simple form which when the component gets mounted, it calls mount. When it gets unmounted, it logs unmount, and it has two very simple input types, a text box and a checkbox. And I am simply rendering this form on screen right now. So this is what it looks like. Nothing surprising here. It's a simple form with a text box and a checkbox. And if I refresh, every time I'm refreshing, it unmounts it first and then mounts it. So wait, let me refresh. Okay, React, since React version 18 is running effects like remounting components on load to showcase unexpected behavior. So I guess it's mounting it, unmounting it, and then mounting it again. So yeah, I don't think we should worry about that right now. But what I'm doing is passing a key to it, which I'm passing via state variable, because I want React to re-render the whole component whenever that key changes, and hence like update the key which is being passed to form as well. And this state key thing is like a simple counter again, like it starts with the initial state of 0, but whenever I'm clicking on reset form, then I'm updating state key by 1. And what this means is that whenever I click on reset form, the key being passed to the form component changes. So what ends up happening? Whenever I'm clicking on reset form, the component gets unmounted and mounted again. So because React thinks that the key to it has changed, it should unmount the previous component and then mount a new component. So you can do this to do useful things like resetting forms, your user end. Let's say you have a form like a text box. It says, I don't know, enter name, and then agree to conditions, I guess something like that. And then you have a long form like this, and then at the end you have a button type equal to submit, called submit, and you want to reset the whole page reset the component without resetting the whole page. So what you can do is that whenever your user hits submit or reset or any other button like that, actually we can just move reset button up there. So, but yeah, that might get a little bit more complex right now. I'll just put it below here. So, if the user makes a mistake at any point, they can click on reset form, you change the key, the component unmounts, a new component gets mounted in, and your problem is solved. This is also useful when you are trying to render two versions of the same component, and the input fields and all of those things get reused because React thinks they are the same component. So in that case, you can give a separate key to both of them, and then all of the internal state that the browser holds also gets replaced. So yeah, that was about resetting state.
Akash, there was one question on YouTube.
Yeah.
They were asking for a clarification on reuse of DOM nodes. What does reuse of DOM nodes mean?
Yeah, reuse of DOM nodes. Reuse of DOM nodes. What that basically means, if I go back here and if I see what's happening, like when I click on reset form. So while we are still on this page, React is, rendering the same form element. It's so basically React is maintaining one reference of a complete DOM node, which is this form element. And whenever we are clicking on reset form, what it is doing is removing that previous element and then inserting a new DOM element in place of it. That's why all of the internal state, like the text that we have entered, the checkbox, all of that are also replaced when we are clicking on reset, because a completely new DOM element takes its place. So by default, React doesn't do that. It's only doing that right now because we are changing the actual key which we are passing to the form element. But otherwise, yeah, it will try to reuse the existing DOM nodes as much as possible. That's what I was trying to go for, I guess. In terms of this, in terms of arrays, for example, if we have something like a counter inside of each of these array elements. So again, the boring counter example, but it's the most useful one that I can give at this point, I guess. So let's say I have something like a div in which I'm rendering the actual state and then a button where I'll just call this increment again. And on click, set internal. Okay. Yeah. I was just waiting for the autocomplete to kick in. Yeah, so if we go here and if I inspect element on this and see the whole component. So this is one DOM node. So this DOM node belongs to the 0th index of child. I mean 0th index for the array of child components being rendered here. And we can see that even if I click on increment, the original DOM node is being reused. So as compared to the previous example, where we saw that the whole DOM node was being thrown out and a new DOM node was being added into its place, we can see that only those parts of this which should change, which is basically, I mean, we are changing the state, we are changing internal state here. So only internal state should be updated in this component. So only that is being updated, only that part of the DOM is being updated, and the rest of the DOM is remaining untouched. So this is what I mostly mean by reusing DOM nodes. And in terms of virtualization is also a part of reusing DOM nodes. In this case, if I open the console for this, and if I try to set row height to 10, okay, oh, I guess 50 was what was the default, and then overscan to 5 maybe. We can see how virtualization works. Basically, instead of creating new DOM nodes every time, it's just reusing the existing DOM nodes, as we can see, and then modifying the CSS in a way that it appears like it's an infinite list. But internally, what it's doing is just using the same set of DOM nodes every time. So this is also something which is very interesting. I'll drop that in the Zoom chat right now, so that you can explore what virtualization looks like. This is another way of optimizing renders in React, and something that you can use as well. So another interesting question after, I mean, if there are any other questions, I'm happy to take them as well for the previous one. But I wanted to move on to why hooks and why useState and useEffect are used. So Kiran, are there any other questions? Sorry.
I put one question in chat. So there was a question on different syntax of setting state.
Right. I think this is more relevant after the topic that I'm going to talk about right now, because I'm going to be talking about useState and useEffect. So I'll just talk about this and then get back into that. Or I think, yeah. So yes, the next topic that I want to talk about is why hooks at all. Why were hooks introduced? This is another very popular uh, interview question with, whenever you're trying to interview for a JavaScript or a front-end based role. And then why do we have useState and useEffect? Why not something else? So firstly, why hooks? Uh, Initially, if you look at how class components in React used to work, okay. Why am I clicking on that? I should just open everything in a new tab. But yeah, if you look at how state in class components used to work, state was a large, a combined object of all of the state that you wanted to use within your app. And you used the way that you used the state was via a weird syntax where you had to write a very long variable, this dot state dot date dot date, or whatever your state key was called. But the main problem wasn't that the variables were long. The main problem was, of course, that the dependency between the state and the function call wasn't very obvious. And for this, let's go to an example of life cycle methods in class components. So we are going to have a look at one of them, which was component did update. This is similar to how useEffect works in that it updates that this function is called whenever a component is updated either via set state or any other function which calls a render. And internally, the user had to write implicit dependencies between the props and what the change in those props should do. So for example, if you wanted to react to a change in the user ID state variable, and whenever the user ID changed, you wanted to make a API call, this is how you had to write the code. So you can see it is very implicit. It's very hard to lint for this by using something like ESLint, because everyone will have different ways of comparing their props and making the respective calls. So because of these implicit dependencies, it wasn't a very good way of defining state and the effects which may occur when those states change. So this is the primary motivation for why hooks exist. And secondly, why use state and use effect? Because they give us a very explicit dependency between states and their effects. And of course, let's just take this example here and try to define what that would look like in React hooks version of the code. You're already aware of this, but let me get back to it. What should I call the file? Let's call this hooks, I guess. And yeah, export function hooks. And let's return null from here for now, because we don't want to render anything. But set user ID, this is just an example again. Use state, and let's say 1. Yeah. So we know that whenever we want to create a dependency between user ID and the effect which makes the actual fetch call. So let's say it fetches user data with I don't know, user ID equal to the user ID which is being passed in here. Then we just do something like this. And since these dependencies are explicit as well, we can use linting and things like that to help check for any issues which might occur. So for example, we saw a yellow squiggly line here just now. So if I try to use a use effect, and I try to make a fetch API call inside of it using a state which is mutable. So user ID can change over each render, and hence React knows that, linters know that. So we can see a yellow squiggly line here, which automatically says that it has a missing dependency called user ID. And these things were just not possible. And this level of good developer experience was not possible with class components. And this is the primary motivation for both useState and the useEffect hooks, providing a good user experience and also making the dependencies much more explicit. So we know that this useEffect will only run when this user ID changes, and then we can follow through all of the various places where user ID is used and set. And that's why useState and useEffect exist. Now, yes, we had a very interesting question about what the difference between sets. That just did something. So, okay, set user ID. And if I set this to a user ID, and if I do something like set user ID and then use the previous user ID, well, let's just use a counter example again, and user ID +1. What happens between both of them? So the main difference is the way that the main difference is when the set state is applied inside of a render. So in the case of the first example, which is the non-callback method, the set user ID user ID gets updated as soon as it encounters this user ID +1. So you might have seen that, you may end up seeing unexpected behavior, because if there are multiple set user IDs in a call, then, and if you are trying to use each of them one after the other, that might result in the user ID being in an unexpected value. But I think there is a much better example for this, which is in callbacks and asynchronous code. So I don't think, I'll have to do a little bit more research to get back into the explanation for that. But basically, the base reason is that in this case, it picks the value for user ID, which is present at that instance during the render. So this will be user ID +1. And then if I have another function call which adds it by 2, this user ID will again pick the user ID instance from here. So that will be 3. But in this case, if I have, let's call this function func1 and func2. Yeah. So in this case, this user ID is referencing to the internal state variable user ID. So at the end of this, it will try to set user ID to 1 + 1, which is 2. And at the end of this, it will use user ID as the internal value and then +2. So it will try to set it to 3. So 1 + 2, 3. So this is unexpected behavior, because one might expect that since this increases the value by 1, this should be at 2 here as well. And then when we are trying to add 2 again to it, then it should be set to 4. But because of the way the normal way of setting state, it can lead to unexpected behavior sometime. But I think the benefit of using this is that it's faster in updating the state as well. So when you are not as much worried about getting the exact value, but you are want to display the results faster, this might be better. But if you want more consistency in terms of how the state is stored, you can use the callback method way of updating state. So in this case, it always picks the correct value. So here, initially user ID will be 1, and then it will try to add 1 to user ID. So it will be 2 here. And React will store this reference internally as the latest value of user ID and not use this user ID. So in this case, it should try to update it. Wait, we'll do this too. It should try to update it to 4 and not 3. I guess we can run it and test it, but that will, I mean, we'll come back to this at the end, I guess, if the question still remains. So let me know. And yeah, I mean, that's generally the difference between the callback method of updating state and the regular method. So yeah, that was about that. And we talked about why hooks and why useState and useEffect. And next, I want to talk about hook dependencies and memoization. We talked about hooks dependencies right now, as we saw, if we, because in hooks, there is a much more explicit relation between the state and the effect. React automatically can tell us whenever a state variable is missing from a dependency parameter for an effect, and that's much more useful. And the second thing that we can do is memoization. So memoization was something that we talked about during JavaScript optimization. So memoizing callbacks and results. And memoization plays a very important role inside of React as well. So what is memoization? I'll try to explain it. Basically, whenever you have a pure function, pure functions are basically functions which, for a set of parameters, always return the same output. So whenever same parameters are passed to the pure function, it always returns the same output. So what kind of functions can you imagine here? So addition is I mean, if you write a function which adds two numbers, that's a pure function. If you try to multiply two numbers, then that's a pure function because the output always remains the same. But you can also define some other functions. For example, what is the current time or what is the current date time? So those are non-pure impure functions because the output changes all of the time, including, if you're trying to fetch a user's profile at a certain time, a profile might keep changing because they might add new data, etc. So memoization isn't helpful there, but it is helpful in some cases. So let's try to memoize a function for addition, for example, or yeah, let's just say addition. And it can accept any number of parameters, and what it does is, I guess, it returns by reducing over it. I'll accumulator and then current value, and then it tries to sum over it. So we aren't going to run this code, but I'm just giving an example of how this might work. So for any number of parameters, it will try to sum over it and return the addition of all of it. Now, how can we memoize this? So what we can do is store the parameters in a list. So we can actually use something, a data structure called a map. So const my map is equal to new map, and the map basically allows us to have any element as the key, any JavaScript element as the key, and any JavaScript element as the value. So in this case, we can also have the set of parameters that we have as the key as well. And what we can do is that we can check for whether it exists in the map. So we can do something like my map dot get params. If it exists, then return it directly, or my map. Yeah, I guess this can be has, and then this can be get. So it just returns the value for that directly. And if it doesn't exist, then compute it and store it. Okay. So this can be something like yeah, so I can actually check for the opposite of it. So if not, mymap.has params, then we can store mymap.set params as the addition of this, and then it returns the cached or memoized value whenever it sees the same set of params again. So in this way we have memoized this, and then whenever we are trying to make multiple calls to addition with the same set of parameters, it will always return the same result which it gets from the cached result. So this is basically how memoization works, and it's actually very useful in the context of React as well, because React functions are immutable by default, and it should always return the same result for the same set of inputs, and so we can use it in that context. Yeah, so I have UseCallback right here, UseMemo and React.memo. These are the three main hooks and functions which use memoization internally for which we can use within your app for optimizing renders as well. Let's start with UseCallback first. I'll just close this for now, I think. And then we can go to our test.jsx. So let's just start something from scratch for now. I'll remove all of the stuff that's already here. Okay, so we have a very simple counter example, and let's say that I am using a function called, I'm defining a function called say hello. Let's define it as a const because that's easier to understand. And what this function does is just log hello for now, I guess, and or not log hello but log count, and then inside of a useEffect I define that this function should be called say hello whenever the count changes, because we want it to react to count. And this is again a contrived example to explain how UseCallback works, but basically since we have now defined a function which is outside of the scope of this useEffect, and we are using it inside of our effect, React will ask us to add that as a dependency, either add that as a dependency, or bring that complete function inside of the useEffect. So this is generally what you would normally do. But let's say what happens if you're getting say hello or any other random function from the parent. So what if I have say hello here, although wait, it doesn't have a parent right now, but what if I define it inside of a child component? So instead of going through all of the steps, let's just say assume it is being passed down from a parent. So what we will do to make this work now is paste say hello in here as well. But okay, that does another interesting thing. So what this says is that this makes the dependency on useEffect change on every render. So regardless of whenever count is changing, this should change as well. So wait, let's say I just call this like this. Yeah, so okay, I'll just run this once and then explain what's happening here. This is in test. Yeah, if I go to console and then I click on increment, hello is being called every time. So yes, I'll explain from the start because I kind of jumped around here a little bit. So yeah, we started with a simple counter example, I mean, that much is pretty straightforward. We have count, set count, use state set, which is initially 1, and then a button which increments the count, and then a div which is just displaying the counter right now. After that, what I did was I created a function internally inside of this component that we had just defined. And then inside of useEffect, I'm calling this component. I'm calling this function whenever I wanted to. So right now it doesn't have any dependencies, but let's say I want it to be called whenever its reference changes. Now, since the function is being defined directly without use callback, whenever a new render is being created, the reference to this function is changing. We can observe that by adding say hello as a dependency to the useEffect. So wait, let me go back here. So whenever we are clicking on increment, the state variable is changing, useState is changing to whatever the latest value from the increment call is. And then what that is resulting in is that it's creating a new render of the complete component. Since a new render is being created, a new reference to say hello is being generated, and hence say hello function is being called every time we are clicking on increment. For each render. So how can we resolve this problem? We can use something called UseCallback, and we can wrap this whole function UseCallback here. Do I have UseCallback imported right now? Yes, I do. So if I refresh this and if I click on increment, then we can see that hello is no longer being called every time. This is because the reference to the hello function has been stabilized by using useCallback. And how it is stabilizing this is basically by memoization. In this case, how it is memoizing it is by passing, by the dependency parameters list. Since the dependency parameters never change, it always returns the same function, and hence whenever a new render is being formed, the function isn't being called again and again via this useEffect. So this is how useCallback can be used. You can use it to stabilize the reference to any function throughout your app. And yeah, again, this was a very contrived example, I guess, but I think it's still very interesting to see how it works. The next one is UseMemo. So UseMemo is, let's go to the hooks reference page for this. I think it's again a very interesting hook that we can use. UseMemo is used to stabilize the reference to a value, while useCallback is used to stabilize the reference to a function. And in this case, what UseMemo basically does is that whenever an expensive computation is created for two sets of values, so let's say that you are trying to multiply two matrices or doing a very expensive computation. In our case, let's say that we are just trying to get the double of a number. So we can use something like UseMemo to write the code for that internally inside of this function. So we can just, return the twice of the count here. Let's assume that, doubling a number is a very expensive operation. And then add it to the dependency parameters for this. If we don't add it, then again, ESLint very helpfully complains that it needs count in there. So we just add it, and then we can display this here directly. So yeah, in this way, we can see that, in the same render, the count is also being incremented, and then the double of the number is also being calculated. And I guess it isn't really as helpful in this example that I've just given right now, but you can test this out yourself. UseMemo basically helps in stabilizing the reference to a value, like we saw for the callback stabilizing method previously. And then we have the final. Before going on ahead, I guess I should take questions for this again. So if anyone has questions, please ask them to me right now.
We don't have any questions yet.
Yes, I am having one question not related to this one, related to that reset button. So you mentioned if we are changing that key, so whole form it will re-render, right? But if we are managing that state in that another component, that parent component, and if we are changing that key, so that form it will re-render and the whole state it will change. Okay, but the state it will be always there, right? So we have to move that reset button state into on the top of somewhere in parent component where we are not storing that state, right?
Yeah, exactly. That so we were passing that as a key to the component. Let's go to the code again to see that. So I think, yeah, this was the more interesting part, I guess, out of this till now. So the key has to be passed to the component itself. So it cannot be a part of the component like here. I guess that's what you're trying to say, right? This key has to be moved out of the component and into the parent, the state for that key.
Yes.
Yeah. I guess you could also pass set key to this component, but then that would be, there might be some cases, for example, if you want to add the reset button inside of this, in that case, you would do something like you could pass the set key to here and then, add that button inside of this as well. Although in this case, I'll need something like this. State key. Yeah. So in this case, this component could be responsible for resetting itself, I guess. So that's something which you could implement. You can try and implement this. I'll share the code for this after the talk. So
yeah, Akash, I have one doubt.
Yeah.
So like using too much of use callback or UseMemo will also slow down your app, right?
Yes, I think again, like there's a lot of doubt. Lot of debate within the React team about this as well. I think like whether UseCallback and UseMemo should be the default or not. I think it is, again, you have to take the best decision by yourself while writing the app. So if we didn't have UseCallback, UseMemo here, right? And let's say this just does, returns 2, I guess. Then or there's some complex computation, I don't know, like 56 into 78, or some very large number, I guess.
Okay.
So if we, by using UseMemo, what we are doing is that we are limiting this computation to only when its dependency parameter is changing. But otherwise, we could do something like, if this was something like double number is equal to this, then this computation will run every time a new render is occurring.
Okay.
Yeah, because as we saw, if we console log something here, I guess without memo and with memo inside of here, and again, this isn't a fair example, but I'll just remove the count dependency from here for now. Let's say this, I can call this double number 1, and then if I go to the test page, yes, so we can see that the with memo function is only called once, but whenever a new render is occurring, because this double number, it isn't using count anywhere inside of it, but the whole VDOM function is being re-rendered again. So that's why this computation is also running again every time. So in cases where, expensive computations are going to be running at every render, it's better to memoize them and then have sensible dependency parameters for that memoization. So the same reference can be reused throughout the app. So, instead of calculating double number at every render, I should just move this into a UseMemo.
Okay.
And so this is how it helps. So again, can it become expensive to use callback and use memo everywhere? Some people say yes, but it's only because the props have to be compared every time. But I think that an equality check is much cheaper than doing the computations again and again, and it just results in it can result in a much smoother app. But again, I don't think, like, instead of very large corporations, we won't generally be running into these kinds of problems in our day-to-day, I think.
Okay. And one more question, like the major difference between a use callback and use memo.
Yeah, the main difference is that use callback can only be used to stabilize the reference to a function. So if we console log this, we can do that, of course. So console log say hello. This is the use callback and this is the use memo. So if I console log double number here, and if we see this, so say hello, I mean, use callback can only return a function every time. So f and then the brackets besides it are a function, and double number was for use memo, so it is returning a value here. So
Okay.
while use callback can only return a function, use memo can also return values, and use memo can also return a function by itself. So if I have something like const memoized hello, and then this returns a function, I can actually move this outside. So let's say const hello is equal to this, and then directly return hello here. And I can also return hello as a value from use memo. Oh, I have to. Yeah. And now if I try to console log this, you can see that, yeah, memoized hello is also, use memo is also able to return a function, but use callback will always only return a function.
All right. Okay.
Yeah. Does this answer things, or
Yeah.
do you
Yeah.
have more questions here?
No. It was my main doubt.
Okay. Thank you.
Thank you. Akash.
Yeah. I guess I'll go ahead to react.memo then right now. So react.memo is, in simple terms, a higher order component. Higher order component meaning that you can wrap other components inside of it. Again, let's go to an example of, yeah. So basically I can do react.memo and then wrap my own component. So if I have a component like export function component which accepts some props and then render based on those props something. Then if I wrap the component in react.memo, what it will do is automatically memoize this component based on the props that it's getting. So the inputs in the previous functions, we were seeing that, here memoize hello, the input for this memoization will be what we are passing in here. For this, again, if it is count, then count becomes the key for the memoization and the value becomes whatever the useMemo function returns. In the case of React Memo, the props are the actual key based on which the memoization is performed. So we have react.memo. Yeah. I should have had a link for this, but I'll just try to drop this in the chat as well. So yeah, this is a higher order component which renders the same result given the same props. And we are going to right now see an example of how this works as well. So there is an interesting thing in React which happens when you have multiple levels of components, which is basically if you have a parent component and the child component and a grandchild component, which is basically state, which is called state cascade. So whenever the parent component changes, whenever the parent component re-renders, it's all of its children re-render as well. That's because React assumes that the state in the parent is somehow being passed into the child and that it should be re-rendered as well. And React developers offer us useful ways to prevent re-renders in this case, and React.memo is one of them. So we are going to have a more in-depth look into how React.memo works now. So I have already created a simple page with 3 components. The first one is the parent component. So I'll just rename this to parent component for now. And this is a this one has the actual counter on it, where on changing, I mean, it has, yeah, the button for increment, and then it is rendering the first child inside of it. And then I'm console logging whenever a render occurs that parent rendered. Inside of first child, I am console logging that first child rendered, and then I'm displaying A and then the count so that we know that the first child is being displayed there. And then it's passing down the count again to the second child, and then the second child is also console logging second render whenever it performs a render, and then it's displaying some values here. So let me go to this page and actually show you how that should work. Yeah, so whenever the page is rendered for the first time, we are seeing parent rendered, first child rendered, and then second render here. So this increment button is part of the parent, then hey is part of the first child, and then second is part of the second child. And we can see that whenever we click on increment, all of the components in the state tree are being rendered from the parent component. So the parent component, all of its children, and then all of the children of their children, and all of the children of their children, all of them re-render every time one of the parents change. So this is kind of like, this can be a big problem in React if you have a lot of components with a lot of computations throughout your app. So how do we resolve this? We resolve this by using the top level API, react.memo, that we had a look at just now. And let's see how that works. As we were discussing right now, react.memo uses the props which are being passed to it for memoization. So let's have a look at second child. Second child is right now just rendering a static number, which was 2. And even though, you know, the props to it weren't changing, it is re-rendering every time its grandparent changes. So let's try to memoize this to solve the problem. So what we can do is const memoized second child is equal to react.memo second child. Okay. And then instead of second child here, we just used Memoize second child, and the props to it never change. As you can see, like the only prop that it accepts is count right now, and it is always at 2. And if we go back here, we can see at the start that parent renders, first child renders, second renders. Okay, this is expected because they're rendering for the first time. Now, whenever we are clicking on increment, we can see that second child is no longer being re-rendered. This is because the props which are being passed to it are constant and never changing. However, if we change the props every time as well, so let's say instead of only passing 2, I am passing count, and count is being passed down from the parent, hence it is like always being rendered. And I'll just add 2 to this so we know that it's different. Now, whenever I'm clicking on increment, then the second child is being rendered as well, because since the props being passed to it are different, the memoization works. The memoization expects a different value to be returned, and then the second child gets rendered as well. So we can actually prevent re-renders at any point by using memoization, as long as the props to it don't change. So let's say that first child doesn't use count at all. I'll remove count from here, then count from here as well. And then I guess I'll just add a static number for now. Again, as in the previous example, we should see that even though no props are being passed to first child right now, it should still re-render every time. Yeah, first child still re-renders even though no props are being passed to it. So if first child is doing some expensive computations inside of its renders, we can prevent it by doing this again. Memoize first child, and then wrap it in react.memo first child, and then dropping Memoize first child instead of first child here. And now finally, whenever we are clicking on increment, only the parent re-renders and none of its children re-renders again. So in this way, again, I mean, this is very complex and you have to do it for every component that you have, but you are able to eventually prevent re-renders again. And since this works like cascade, so the second child previously was re-rendering because first child was re-rendering, and first child was re-rendering because its parent was re-rendering. If we try to stop it at the root, so right now, for example, I have memoized first child, but I've removed the memoized version of second child. Second child should still not re-render every time because first child's re-renders are being prevented by its memoization. So to have a look at it, I'll refresh this page again. And if I click on increment, yes, we can see that second child is no longer being re-rendered every time as well. So this is how react.memo can help you in bringing more stability to your apps and optimizing renders. And secondly, again, we are at the very near end of this talk, so don't worry. There's not a lot more to learn about today. Yeah, next up we have UseRef. UseRef is the best because the best way to avoid renders in React is to not have any renders at all, and UseRef doesn't re-render whenever you change the value inside of it. So for this, I'll create a new page called ref.jsx, and then I'll do something like ref. And I guess we try to render something on screen right now because otherwise we won't see anything. So what's this complaining about? Default function. Yes. So current mouse position, let's say. I don't know. And I'll try to set the width and height to 100%. So we can capture the mouse position throughout the screen. Now, let me go to /ref here. Okay, current mouse position. And if I check the div, okay, so we can see that the div is taking the whole width and height of the page. So now, again, this is a very expensive operation. So what if we try to do something like mouse position, right? Set mouse position, and then use something like useState to store the values for that. So x0, y, or let's say both of them start with null because they won't really start at 0. And then on mouse move, we set that to set mouse position x. Oh yeah, I need e, I guess, and then e dot client x, and then y, e dot client y, and I guess we just display that here. So something like mouse position dot x and mouse position dot y. And if we try to console log this in here, so console log render, we can see that you can see how expensive this becomes. I mean, how quickly, how expensive this operation has become for us. Because every time we are moving the mouse, a new value is being stored into set state and a new render is being formed. So imagine how this would work for extremely complex components. So for cases like this, instead of storing the values in a value which will cause a render every time, it is much better to use something like UseRef. So and UseRef is very useful again because you can access its value anytime throughout your component. So instead of retaining at array, it just returns the value. And to update a UseRef is very simple as well. You just use mouse position dot current to the value that you want to set it to, and to display it. I mean, of course, we can't react to it anymore, so we won't see the latest value for mouse position every time, but we can do something like this. And then we can say that on mouse click, wait, on mouse down, I guess, yeah. We can cause a render, or what we can do is also add another state. So reported position, and yeah, this is again a very bad example of how this should work, I guess. But wait, what should this do? On mouse down, I guess we can just console log this for now. So console log mouse position dot current, and then you can see that whenever you are moving your mouse throughout the page, it no longer causes a re-render, and whenever you are clicking, it just gets the latest value of your mouse position at that point. And hence, instead of wasting a lot of renders, you can just store that value in a UseRef and then use it at a later point whenever you actually want to use it at, instead of reacting to it every time. So this is how UseRef is pretty useful for us. Lastly, we have UseContext, which is again something which is very controversial, because generally UseContext is seen as a state management tool, but it isn't exactly a state management tool. It is actually useful for avoiding prop drilling in your apps. And we are going to see now why you shouldn't use UseContext for state management. So I have a file called context.js here. Here I have defined a very simple context. I'm using my context to create an empty context, and then I'm creating a context provider using the context created here, which basically takes some children and then some values, and I can pass some values to it and wrap my components with my context provider, and then all of the children of that component will get all of those values as well. So similar to our state cascade example, I have a grandchild component, I have a child component, and then I have a parent component, which has all of those components inside of it. I have the count, again, our good old counter example, and then the data is being passed throughout this. So I just need a button here again. Button on click. Yeah, if anyone has any questions for the things I've talked about so far, I'm happy to answer them. About either UseRef or the state cascade problems that we saw, or memoization.
Hello, Akash.
Hey, Gokul, yeah.
Yeah. So I've been wondering, like Figma, the Figma tool, it actually uses React, right?
I actually don't have the answer for that. I think
Yeah.
it does use it partly, but
yeah. So, but in Figma, like for example, we have a lot of mouse movements and these changes, right? Which is constantly.
yeah.
So, like, what do you think from your understanding? Like, will they be mostly using this reference, like UseRef or useState, like, or combination of both?
Yeah, I think it would be a combination for both, of both. For example, like you can still, of course, get the exact mouse positions, exact coordinates of the mouse when you are doing something like a click, because I mean, if I go back to the previous example, I used the values from mouse position dot current here, but then I can also just use, e dot client x and e dot client y. So they don't really need to store the values every time when they're recording things like clicks, I guess. But of course, like we see in Figma that they're, showing mouse positions across screens as well, and they sync it quite well. So I
Yes.
think they are storing the values intermittently, like they're using either throttling to, like, reduce the number of mouse positions that they are storing, or they are just pinging the client every time to see where the user's mouse is at a time, and then syncing it across their devices. And then there is actually a concept called interpolation in animation. Interpolation. Yeah, so instead of us seeing jagged mouse movements like this, they are taking those individual values and then trying to animate over it. So this is interpolation animation. If you check that out, so you'll see that even with less number of coordinates, they can actually act like they have all of the coordinates with them, and then display the mouse movements for that.
All right. Okay.
So yeah.
Sounds
So
good.
they are probably doing a combination of both, as you said, and then faking the animation of the mouse movement for that.
Hmm.
Yeah. There are actually several animation libraries as well for React. So like Framer Motion, you might have heard of. So you can have a
Yes.
look at that. Yeah. Any other questions? I guess I can go ahead with context then. So if I go to localhost 3000/context, and I guess there is no real differentiation here about how this works. So I mean, we can't really differentiate the components here, so I'll just add a new div which says child component here. Yeah. So the parent component contains the button, and it is passing, the state via context to to the provider, and rendering the child component. So this doesn't get the state itself, but it is just passing it down to its grandchild. I mean, the grandchild is getting it via UseContext. So what is the problem with UseContext right now? If we try to refresh this and increment, as we saw previously, firstly, because of state cascades, our child component gets re-rendered every time the state of the parent changes, because React just does that, I guess. So we will try to first fix this component by memoizing it. So we do memoize child to, as we saw, to prevent the re-renders of child component that we are seeing here. So we can do memoize child is equal to react.memo child component, and then use memoize child in here. So whenever we are refreshing this page, whenever we are clicking on increment, we can see that even though the child isn't being rendered anymore, the grandchild is still being re-rendered. Now, why is that? Previously, we saw that, in the state cascade example, when we try to memoize the first child, the grandchild automatically stopped re-rendering every time as well. But that's no longer the case. So that's because whenever you pick a value from the use context, even if you are not using the exact value, so in this case, we are only passing down count and then we are using it. But it could be possible that we have count and then some other value which we are not using. Let's say this is set to 2. So we are, instead of using count, I'm using some other value here and then rendering that. So that's complaining because it's trying to parse it as TypeScript here. But let's say I just refresh the page and then click on increment. We can see that even though we are getting some other value from the context, grandchild is still re-rendering. And that's because context doesn't have the concept of like individual state. It is a combined state object. And even if you pick any other value from the context will, when the context's value changes, it will still make your component re-render. So that's why it isn't the best in terms of state management, because if any other part of the state changes, your complete component re-renders anyways. And the main purpose of context was to avoid prop drilling, but by avoiding prop drilling, it's just adding other problems to your app. So that's why UseContext isn't the best state management solution. So what should you use instead? So there's something called useState. Most of you guys might have heard of this already. So if you go to useState and you see how it works, what it does is it basically creates its own context outside of the context of your React app. And then whenever you're trying to add state or access state from it, it just uses its internal context inside of your apps. And it doesn't make your app or your components re-render every time, because it doesn't wrap your app in its own context providers. So you don't have any context providers. So you avoid a lot of the re-renders again. So this is how, state management libraries like useState help as well. And yeah, so that was pretty much the end of my talk. I think this was a very long 2 hours, but I think I hope it was very interesting for you as well. If you have any questions for me, if you have any questions for me, you can drop them to me on @thewritingdev on Twitter, or reach out to me on my website, thewriting.dev. So yeah, I'll stop sharing my screen and I'm happy to take any other questions.
Nice workshop, Akash. Very informative.
Thank you. Thanks, Kiran.
And covered a lot of good points.
Yeah. I could have done it a lot better, I think, but yeah, with the limitation of place and equipment that I have right now, I've tried my best, I guess.
Yeah, it was really informative, Akash.
Thank you.
Akash, one more doubt, like in terms of state management, which tool do you think is the best right now? There are a lot of right now, like Jotai and Justan, Recoil, everything.
Yeah. Basically, I don't have my opinions, my own opinions about state management right now. I have outsourced all of them to this guy, Daishi Kato, who has created ZooStand, and I think he was involved in the original Redux libraries as well, if I'm not mistaken. And right now he's very bullish about ZooStand. That's why I like ZooStand quite a bit.
All right. Okay.
Yeah.
Even I'm using Justand in one of my projects. It's working out well so far.
Oh, nice. Kiran, maybe you can talk about your experience a little bit with state management libraries.
Yeah, even I was like, trying everything in the sense, earlier we used to do Redux a lot, and then, we stopped doing Redux. Yeah, now I was leaning towards Justand. Yeah, and some people are saying Jota is also good, but I haven't tried Jota yet. Yeah.
Yeah.
The only thing, the only concern I have with the Justand is it didn't have a concept of derived state, in the sense, for example, let's say we have two state property, we want to create a new state based on the existing state. There is no straightforward solution directly coming from the library itself. We have to figure out our own ways of doing. Other than that one particular use case, remaining everything else seems to be fine.
I see. So I guess in terms of derived state, then you have to write custom code to be able to like merge those two states by yourself, I guess.
Yes, yeah. So like I'm currently kind of using a hook, custom hooks kind of thing, in the sense, but that hook will get the two state properties and do the math and give me the derived value. I'm using that. That's fine. But if something like, for example, Mobits has a built-in derived state feature, right?
Right.
That is not there in Justan. Yeah.
I see.
But it's also like Mobits is like very big library. Justan is like very tiny. So I think it's a trade-off, I guess. But yeah.
Yeah, but good to know about it, I guess. I guess no one else has a doubt right now. Is there anything on YouTube?
Akash, there is any specific scenario, so we can use either Redux or UseStand or Jotai. So that will support in our application.
I haven't faced any particular scenario yet where that has occurred. But again, in the future, if I would try to, I mean, if I had a very complex app, if I was storing user information on the parent and I mean, on the top level component, whatever you call it, layout or parent or app or whatever, and I wanted to access it very deep within the app, or like if I was trying to build a very complex form which had lots of states which I wanted to access throughout subcomponents in that form, I would probably go for a state management library in that case, because writing all of those selectors and all of those things by yourself, it gets very complex, and I don't like the syntax of use reducer basically, because it's very hard for other people to understand.
Yeah.
So yeah, I'll probably go for a simpler solution like ZooStand, I guess.
Yeah. So on YouTube, we have one question, like how do you measure performance of React components?
Yeah, I guess I don't have a specific answer for that. There are like many ways that you can do that in. You could use something like React Profiler as well. I think the creators of React Profiler have lots of good talks on how you can use it to measure the performance of your components. I'll try to search for some of them and then share them on Twitter, I guess. So you should follow me on Twitter for that.
Great. Yeah. Yeah, I think that's all the questions we have. Yeah. So as Akash said, follow him on Twitter. He keep putting a lot of good content out there, and yeah, do follow him on Twitter. And do you have anything else?
Nice. Nope. Well, it was nice giving a talk here. I think this has been my first talk in quite a few months now, and yeah, it was a nice experience, I guess, and I hope to do a lot more better in the next talk that I give in Reactify.
Sure. Yeah, we can plan more in coming future. Yeah.
Yes.
Thank you, Akash.
Thanks, Rohit.
Yeah, thanks, Akash. Yeah, thanks everyone for joining. So
thank you.
Yeah, we'll see in our upcoming meetups and events. Yes, see you all again soon.
Yes. See you. Bye.
Bye.
Yep. Yeah. Hi, Kiran. Hello.
Yeah.
Kiran. Yeah. This is Shivraj here. I have a small. Recently, I started developing in React, and small project I have done already. So I want to host it. So which you recommend? Hurak or some kind of something like that. I want. I have a space in GoDaddy, but that doesn't work. So which one you suggest or something like
that? You want to deploy an application, right?
Correct. Yes. I want to deploy an application.
Is it for production?
Yes, production. I own some small work, so I want to see